This sheet is going to help you understand the vocab behind angle measures. This is a very quick sheet for us to look at, and then we're going to move on to the one that actually involves math, okay? We are talking about angle measures. So we've already done segment addition, angle addition. We know how to name them. Now what we're going to do is talk about those special types of angles and the vocab word that goes with them. Your flip book should look like this. I would like you to open up where the tab that says angle measures. Open it gently and then crease it so you can write. Okay, so we've already talked about an angle is formed by two rays that have a common endpoint, which we call the vertex. We already know this. This particular angle right here, we've already practiced this. I want you to name it 4 different ways on your paper. Name this angle 4 different ways on your paper. Recall what we learned 2 days ago. The 4 different ways to name a possible angle based on what's labeled. All right, name one of them. ABC. And that's because what letter is the vertex? B. This is the vertex. Okay. What's another possible name for it? CBA. Again, the vertex is the middle letter. Has to be that way. What's another possible name? You can call it angle 2 because of the floating 2. And another. Remember? What? Angle B. So you can name it by 3 points, reverse or forward. You can name it by a floating number, or you can name it by just the vertex itself, if there's only 2 rays coming out of it. Okay, please gently fold the next flap, and let's just really quickly talk about what does it mean interior versus exterior of an angle. So if you look at this picture, and I'm going to highlight, you don't have to necessarily highlight. You could lightly shade your pencil if you wanted to. But interior would imply that if the angle was completely closed and it was opening up, right, the interior would be the points between the 2 rays. Of course, this would extend on, but it would be the points between the 2 rays. The exterior would be the points behind it. Does that make sense? So if you have a highlighter and you want to highlight, you can. You don't have to. You could lightly shade with your pencil. But I need you to understand the difference between the interior and the exterior. But we do have a very quick question here. It says, name the points on the interior of angle ABC. We could say points D and G. Now you might say, what about E? We're just going to ignore E. E's kind of one of those questionable ones. I think E is tricky and I don't like tricks. So, okay, coming down here, name points on the exterior. You would say F and H. And that's it for this flap. Remember what I said, this is a very, very quick little lesson. I like it because it's a flip book, it's a brain break, I like the graphics, it's short, sweet, to the point. So now we are ready to lift the last flap and look at the last page, okay? This page is the most important, right here. The three vocab words are in bold, in the black box. You have acute angle, right angle, obtuse angle. Okay? Do you know what you call a baby that a geometry teacher has? Acute. Sorry, that's really lame. When I was pregnant, I've had two boys, and every time I was pregnant, I would be like, "Y'all, I had an acute baby." All right, anyways. So what does acute mean? Acute means in reference to the size of the angle, it's going to measure less than 90. Y'all, is that too much? I've lost them. They're gone.
It was funny.
I think it's just that they're laughing because they're laughing. You know what I mean? Like,
they're laughing at the fact that
yeah, that they're laughing. He's gone. He's gone. He's done. Yeah, he's on a new level. He's trying to get it under control. All right, if you would come right here and write the definition for acute. The measure of an acute angle is always less than 90 degrees. Now, the technical definition, this is really fancy here, look at this, is that it would be between 0 and 90. That's the technical inequality. Now, a right angle is something y'all said y'all learned in middle school, because yesterday when we had that sheet, I wanted to make sure you knew what the little box meant. When you have a square drawn in the corner of an angle, it means that this is 90 degrees. And that is the symbol for the picture without them actually writing 90 degrees. So a right angle measures exactly 90 degrees. Not 90.1, not 89.9, 90. Okay? Not a wrong angle, but a right angle. That one was. And then the third one is obtuse. Obtuse measures more than 90 degrees. I've run out of room. I hate to. I'm going to actually turn that into 90, and I'll just move the C to right there. There we go. It measures more than 90 degrees, but also less than 180. It doesn't hyperextend. So it's between 90 and 180. So here's that fancy way of writing that. These three vocab words are very important. Very, very, very important. You're going to hear them a lot, and you need to associate the definition with the vocab word. Now, let me show you a stupid, corny little way to help you remember. The word acute, the word right, the word obtuse. Most people have a right angle already committed to memory. It means 90, okay? The problem is acute or obtuse. Here's the way that I teach people to remember it. Think, you have to watch me. Acute, right? I told you it's stupid. Acute, like a cute little thing. Acute meaning small, and then think, I have to be dramatic here. Obtuse, right? You with me? Okay, so acute, almost like someone sneezing, and then obtuse. Okay, I'm sorry. I swear it's going to work, though, y'all. It's going to work. So acute measures less than 90. Obtuse is opening up. Think if your mouth opens bigger to even say the word, and it measures more than 90. Okay. Now, what is this? Ha ha! It is not a left angle, but it does open to the left, and it's still a right angle. friend of mine teaches middle school, and she noticed one year that she always draws her right angles opening to the right, and one day it was the other direction, and a kid was like, "Is that a left angle?" Which makes perfect sense because it's facing the other way, you know? And it does not have a different name. It's still a right angle. So if you need to draw, let's see, is there room? I'm glad you said it. I'm so glad. If you need to draw one like this, right there, you could draw that it, could also look like that. That's still a right angle.
If I draw that, put a left angle. I'm doing that.
And then we have one last spot to talk about, and then we're moving to the next sheet. So this right here, we've already done this. Just underline angle bisector, divides an angle into two congruent halves. So now this picture, I would say, is terrible. It's not drawn to scale at all. But we're going to pretend like they're equal. It says that ray DG is an angle bisector to angle CDF. Well, then that would mean that this part is congruent to this part. Now we need to write the congruent statement. So we're going to carefully trace the angles with our pencil. We would have angles CDG congruent to angle GDF.